In the current market, the cost of executing professional-grade autonomous software engineering has dropped by an order of magnitude. Frontier-tier coding intelligence now operates at a small fraction of the price it commanded only a few months ago. Cursor's latest release, Composer 2.5, matches the performance of industry leaders like Anthropics Opus 4.7, while simultaneously reducing the cost per task 20-fold. Previously, running continuous autonomous coding loops on premium models was a significant resource drain, often exhausting a developer's entire daily quota in a single session. This shift in pricing forces a change in how developers structure their daily workflows and allocate compute for complex tasks. We are going to analyze the quantitative benchmark data, the underlying model architecture, and the specific qualitative failure modes to see how this transition was achieved. In this new environment, raw intelligence is no longer the sole bottleneck for agents. Cost efficiency has become a primary metric for developers. To measure this shift objectively, we look to the CursorBench 3.1 results, which test models on complex, multi-step engineering tasks. This chart displays coding agent rankings. Opus 4.7 Max holds a 64.8% pass rate, costing $11 per task. GPT 5.5 follows closely at 64.3%, costing $4.37, but Composer 2.5 achieves 63.2% for just 55 cents. For a developer's daily resource allocation, these numbers mean the difference between a high-stakes decision and a routine utility. The economics are clear. One complete task on Opus costs as much as 20 iterative loops on Composer. This 20-to-1 ratio changes the nature of the trial-and-error debugging process, allowing for dozens of exploratory attempts to solve a single bug. Agentic debugging becomes a frictionless, standard procedure rather than a heavily scrutinized expense. Composer 2.5 commoditizes the top-tier performance bracket, making high-level reasoning accessible for continuous, everyday use. Cost is only half the equation. In autonomous coding, execution speed is the secondary bottleneck that often dictates whether a tool is actually used. Composer 2.5 is built on the Kimi 2.5 open-source checkpoint. Cursor surrounds this core with a proprietary model harness, an environment optimized to route complex instructions and handle sustained tasks more effectively than a generalized model. This chart from Artificial Analysis shows the average time required to complete a task. The Composer 2.5 fast variant averages 6.7 minutes. Other frontier models performing the exact same tasks frequently require 10 to 15 minutes to return a result. This metric, the speed-to-intelligence ratio, is what keeps a developer engaged with the tool. When an AI takes too long to return code, developers hit a psychological threshold where they switch to a different task, losing their active context. A sub-7-minute execution time allows the developer to stay in their flow state while the agent works in the background. By lowering both the financial and time costs, this architecture enables a tier of continuous, real-time agentic collaboration. For years, skeptics argued that third-party IDEs were merely API wrappers that could never compete with the companies building the base models. Composer's harness demonstrates that optimizations at the execution layer can outperform generalized models in professional environments. Maintaining a competitive technical stack requires constant monitoring of these shifting economics. Subscribe to this channel to get technical evaluations the moment new benchmark data becomes available. While the benchmarks are impressive, they don't capture every aspect of model deployment. There are still areas where Composer 2.5 struggles. A clear capability gap appears in front-end web development and tasks requiring precise spatial reasoning. Opus 4.7 is currently the standard here, with a native ability to infer design standards and generate polished, logically consistent SVG environments. In contrast, Composer 2.5 can execute the requested code correctly, but will occasionally hallucinate the structural relationships between objects on the screen. In testing, the model generated an SVG skyline and ocean, but misplaced a ship so it was floating in the sky rather than the water. Similar logic failures appear in 3.js simulations. The model generates a Formula 1 environment, but the underlying physics logic often fails. Architecturally, Composer tends to overcommit to a single path during complex generation, rather than stopping to weigh different design trade-offs. Because of this, achieving high-quality aesthetic results with Composer requires a different approach to prompting. Bridging the visual gap with Opus requires the developer to provide highly rigid, specific design specifications, taking on the spatial reasoning themselves. Back-end logic is now highly affordable, but premium spatial intuition and autonomous design taste still require a frontier model premium. The primary takeaway from Composer 2.5 is that an optimized implementation layer can effectively replace massive frontier models for most daily coding tasks. This model unlocks a massive volume of compute for the individual. Standard subscription limits now offer enough headroom for near infinite daily usage. While it trails the bleeding edge in front-end design, its reliability in debugging and terminal operations is excellent. By lowering the task cost below $1 and minimizing wait times, Cursor has changed the nature of the developer iteration cycle. Over the past year, many automated workflows have been restricted by high cost per token limits. Leave a comment below detailing how these financial restrictions have impacted your own projects over the last 12 months. If you found this technical analysis helpful, please leave a like and subscribe for further evaluations. Success in the coding agent market now depends on which ecosystem delivers high intelligence with the lowest latency and cost.